Today we're going to take a look at 9-2 lines of best fit. So we're going to figure out what a line of best fit is, and then you'll have an opportunity to look a little bit ahead to figure out how to do that with technology. First thing I'd like for you to do is go ahead and do your warm-ups. Hit pause and then play to continue. All right, for number 1, you should have ended up with y equals -1/5 x plus 4. For number 2, you should have ended up with y equals -3x plus 6. And last but not least, you should end up for number 3 with y equals -1/2 x plus 7. Now today what we're going to do is look at a scatter plot. Now a scatter plot is going to be exactly that, where data is kind of scattered amongst a graph. And then what we're going to do is create a line of fit. A line of fit is drawn on a scatter plot that is close to most of the points. It can be used to estimate data on a graph. So what we're going to do is we're going to graph some points, and I'm going to show you how to find a line of fit. All right, taking a look at example 1, we're going to go ahead and make a scatter plot. So I'm going to graph these. Now it tells us this x is months, and then this is depth in feet. So we're looking at the amount of rain months after a monsoon season. So what is the depth of the river? So here, let's see, I've got 2, 4, 6, 8, 10, 12, and let's see, 4, 6, 8, 10, 12, 14, 16, 18, 20, whoops, got a little ahead of myself here, 16, 18, 20, 22, 24. So I'm going to go ahead and graph this. Hit pause, and when you're done plotting those points, hit play. All right, now it looks like we have a linear equation here, but as you can see, it's really not a straight line. So what I'm going to do is I'm going to use my ruler here to try and go through. So I kind of have half the points above, half below. So I'm going to go through right about like that. Now, it's an estimation, so everyone's line may be a little different, but we should be pretty darn close. So now what I want to do is write an equation of best fit. So what I'm going to need to do is come up with 2 points. So I'm going to use 5, 10, and 0.68. Now again, this is an estimation of this line. So how do I graph, or how do I write an equation with 2 points? Well, first we're going to find our slope, which is change in y over change in x. So let's see, I've got x1, y1, x2, y2. So I have 8 minus 10 over 6 minus 5. So I have -2 over 1. So my slope is -2. And since I have a y-intercept here, which is nice, of 0, 20, I can go right to y equals mx plus b. So y equals -2x plus 20. So here's my b, here's m. Next, it says interpret the slope and the y-intercept of the line of fit. Now, again, interpret doesn't mean state, it means explain. So first, I know that my slope is -2. So what does that mean? It means the depth of the river decreases 2 feet per month. Now, my y-intercept was 20. Again, I need to explain that. What that means was the depth of the river is 20 feet at the start of the monsoon season. All right, so it says predict the depth in month 9. Well, I can go back to use my equation here. So y equals negative 2x plus 20. Now I'm going to use an x of 9. It's my 9th month. So I have y equals negative 18 plus 20. So y equals 2. So the depth of the river should be about 2 feet. All right, go ahead and try on your own. What I'd like for you to do is hit pause, and then when you are all finished with A, B, C, and D, hit play to continue. Now, again, keep in mind this is a line of fit, which means our answers may be a little different based on what numbers you used, but your final equation should be pretty darn close. So I ended up with the slope of 283 3/10, which is about 280. And since my y-intercept is 0, my equation is y equals 280x. So my slope is 280, which means the attendance increased by about 280 people a year. And the y-intercept is 0, so the attendance in a year prior to this was 0. And then if I look at year 10, it should be about 270 people or 2,700 people that I can use kind of by an estimation here. Or if I were to use my equation, I'd have an estimate of multiply by 10, 2,800 people. So as you can see, your answers may vary depending on what equation you use, and that is okay. They are still pretty darn close. Now, one of the things that we can use is a graphing calculator. So this is more of an FYI kind of piece. We're going to go ahead and take a little look at this one. So graphing calculators use a method called linear regression to find a precise line of fit called line of best fit. Now this line models a set of data. A calculator often gives a value R called the correlation coefficient. Okay, this value tells you whether the correlation is positive or negative, and how closely the equation models the data. Values of R range from 1 to negative 1. When R is close to 1 or negative 1, there's a really strong correlation with the variables. As R gets closer to 0, the correlation becomes weaker. So if I take a look, if my R is close to negative 1, that means I have a strong negative correlation, like a negative slope. And if I have R equals 0, there's no correlation, which I referred to as kind of a hot mess type of graph before, where data is all over the place. But if I have a correlation closer to 1, that is a strong positive correlation. I've got correction, correlation, I'm sorry. All right, now this next part's not going to be on your quiz, but there are some great directions here for you on how to find a line of best fit using a graphing calculator. Now, you're welcome to do this on your own if you'd like, but again, this will not be on the quiz. But I have given you very specific directions here on what you need to do. And so you can kind of take a look and fill some of this in. Again, this will not be on the quiz. There's also a great YouTube video where I put the link right here for you to find a little bit more information about creating a line of best fit using a graphing calculator. Again, this part won't be on the quiz, but I did want to put it out there for you just in case you'd like to take a look. All right, have a great day.